And girls, today we are going to talk about Unit 4, Module 3, Session 1, Part 2, and this part is called Measurement Benchmarks. So we will begin this lesson by taking a subtraction checkpoint, which you've actually already done, and then I'm going to introduce the measurement benchmarks and scale by having you listen to the book Hottest, Coldest, Highest, Deepest by Steve Jenkins. And then we will list and discuss some of the different units used to measure length and distance, and then spend time using rounding to answer questions about measurements. So over the next week or so, we're going to be measuring and comparing items. Today we're going to learn some amazing places on Earth and think about how people use measurement every single day. So I'm going to read aloud a book called Hottest, Coldest, Highest, Deepest by Steve Jenkins. Before I read, though, I want you to think about these questions. Question number 1, what is a benchmark? Question number 2, why would the author use benchmarks in this book? Question number 3, how do benchmarks help us to visualize measurements? And question 4, why does the author mention certain measurements for certain things? Now, when we think about benchmarks, first of all, it's not benchmark the curriculum that we have for reading. This is a different kind of benchmark, of course, because we're talking about math right now. So think about benchmark when you think about math for a minute, okay? Why would the author use benchmarks in this particular book? And how do benchmarks help us to visualize measurements? And we actually also use benchmarks when it comes to science. So just keep those questions in mind, okay? So now I'm going to read to you Hottest, Coldest, Highest, Deepest by Steve Jenkins. If you could visit any spot on Earth, where would you go? What if you wanted to see the most amazing natural wonders in the world? There are deserts that haven't seen rain for hundreds of years, and jungles where it pours almost every day. There are places so cold that even in the summer, it's below freezing, and spots where it's often hot enough to cook an egg on the ground. There are mountains many miles high and ocean trenches that are even deeper. You can find rivers thousands of miles long and waterfalls thousands of feet high. Where are the very hottest and coldest, windiest and snowiest, highest and deepest places on Earth? Travel the world and visit the planet's record holders. So here we have that the U.S. is 2,750 miles wide. The Nile is 4,145 miles wide. The Amazon River is 4,007 miles long. The Chang-Jiang, I think that's how it's pronounced, sorry, is 3,964 miles, and then the Mississippi to Missouri is 3,740 miles. The Nile in Africa is the longest river in the world. It is 4,145 miles long. The Amazon River in South America is not as long, 4,007 miles, but is considered mightier because it carries half of all the river water in the world. The Chang-Jiang, or Yangtze, in Asia is 3,964 miles, and the Mississippi, Missouri in the United States is 3,710 miles. Those are the world's third and fourth longest rivers. Lake Baikal in Russia is the world's oldest and deepest lake. The lake was formed about 25 million years ago. In one spot, it is 5,134 feet deep. The largest freshwater lake in the world is Lake Superior, one of the Great Lakes in North America, 31,700 square miles. But Lake Baikal, 5,500 square miles, contains more water than any other lake on Earth, more than all 5 Great Lakes combined. That's pretty crazy. Mount Everest is the highest mountain in the world. Its peak is 29,028 feet above sea level. Mount Everest is considered the highest mountain above sea level in the world, but it's not really the tallest. Measured from its base on the floor of the ocean, Mauna Kea in Hawaii is 33,476 feet tall. Only the top, 13,796 feet of Mauna Kea, are above sea level. The hottest spot on the planet is Al Azizia, Libya, in the Sahara, where a temperature of over 136 degrees Fahrenheit is recorded, or has been recorded. The hottest temperature ever recorded in the United States was 134.6 degrees Fahrenheit in Death Valley, California. The coldest place on the planet is Vostok, Antarctica, a temperature of 129 degrees Fahrenheit below zero was recorded there. It is so cold at the South Pole that the average summer temperature is negative 58 degrees Fahrenheit. The coldest temperature ever recorded in the United States was negative 80 degrees Fahrenheit at Prospect Creek Camp, Alaska. And the wettest place on Earth is Tutanendo, Colombia, where an average of 463 inches of rain falls every year. Mount Waialele, it's hard to see that, on the island of Kauai in Hawaii has the most rainy days at 350 a year. The island of La Reunion in Indian Ocean, more than 61 inches of rain fell in a single day. The driest place is the Atacama Desert in Chile, where no rain has fallen for the last 400 years. Any place that receives less than 10 inches of precipitation a year is considered a desert. The driest place in the United States is Death Valley, California, where only about 1.5 inches of rain fall every year. And the windiest spot on Earth is atop Mount Washington in New Hampshire. A wind speed of 231 miles per hour has been recorded there. It is also very windy near the tops of the world's highest mountains, the Himalayas. Many of these peaks are tall enough to reach a jet stream and narrow, strong air current that is found above 28,000 feet. The world's highest waterfall is Angel Falls in Venezuela. It is 3,212 feet high. Angel Falls is more than 17 times higher than Niagara Falls, 180 feet. In New York State, Victoria Falls in Zimbabwe, Africa, carries more water than any other waterfall. It is 355 feet high. The deepest spot in the ocean is the Marianas Trench in the Philippines. It is 36,202 feet deep. The average depth of the world's oceans is about 3 miles or 16,000 feet. The lowest spot on dry land is the shore of the Dead Sea, 1,100 feet below sea level. And the world's most active volcano is the Sangay in Ecuador. Since 1937, it has erupted once every 24 hours on average. It once erupted more than 400 times in a single day. Other very active volcanoes include Colima in Mexico. It has erupted regularly since 1560. Also, Aso in Japan, erupting since 533, and Mount Etna in Italy, erupting regularly since 1500 BC. So before I read the last page, I want to do a little comparison problem for you about these waterfalls. And I may end up asking you to do one eventually. I may not, just depending on how much time we have and things like that. But just for now, I just want you to follow along with me, okay? So how much higher is Victoria Falls than Niagara Falls? I like the constant difference strategy for this particular problem just because of the numbers that we're dealing with here. So when you look at 355 feet, and I know it's very blurry and I apologize about that, and you look at 180 feet of Niagara Falls, I'm looking at 180 real quick, and I can see that it's very close to 200. So all I really need to do is add 20 to it to get to 200. So I figure the constant difference strategy is really going to help me out for this particular problem, okay? I don't really want to do the standard algorithm of subtraction because I'm going to have some regrouping and I just don't want to deal with that. So if I'm already 20 away, let's just do the constant difference strategy where we're going to add 20 to both of them, which will end up giving us 375 minus 200. Now when I'm looking at it, it looks a lot easier to subtract, right? Because I can simply just go like this, and you can see that I have 175. So how much higher is Victoria Falls than Niagara Falls? Victoria Falls is 175 feet higher. Now, like I said, I may end up asking you to do a problem like this. I may not. It all just depends on how things are going, okay? All right. Moving on here, here's the last page of our book. The most extreme tides occur in the Bay of Fundy in Nova Scotia, Canada. The water level rises and falls more than 50 feet every 6 hours. The tide here comes in so fast that it can overtake a person trying to outrun it. The snowiest place on Earth is Mount Rainier in Washington State. One year, more than 1,200 inches of snow actually fell. Mount Rainier is covered in snow the whole year. Some of the snow has formed glaciers, masses of ice that slowly move down the mountain under their own weight. Okay, so we have now concluded our book, but we are probably going to end up coming back to that book, so keep this book in mind, all right? We're going to switch gears a little bit here. Here is a list of the measurements that the author used to describe the most amazing places on Earth. At times, like I said, we will revisit sections of the book. So remember, there are many different ways to measure things. So when you want to talk about like a record, we have the words longest, oldest, deepest, largest, highest, tallest, hottest, coldest, wettest, driest, windiest, most active, most extreme, and snowiest, okay? And then in units, you can measure things in miles, years, feet, square miles, feet, degrees Fahrenheit, inches, miles per hour, hours, days, years, okay, feet and inches again, all right? So there's just some ways that these are just record measures. Okay, so these are some measurement words that we might use. So for length, measurement words we would use would be inch, foot, yard, mile, centimeter, and kilometer and meter, okay? There's also measurement words for time, mass and weight, and volume and capacity. But for today, we're just going to think about these particular words right here when it comes to length, okay? All right, so mountain heights. We heard about a couple of different mountains, but here we have Mount Everest, and the height of Mount Everest is 29,028 feet. Rounded to the nearest thousands, okay, would be 29,000. Now, when I'm rounding to the thousands, we've talked about this before in class, we always want to look at the number in the hundreds place, and you can see that it is a 0. So if it's 4 or lower, the number that you're rounding to, which would be this 9 here, is going to stay a 9 because this 0 is basically making it stay a 9. If this number in the hundreds place were 5 or higher, we would then round up, okay? But in this case, it's a 0, so it's going to round to 29,000 feet, okay? Mount Denali is 20,320 feet. That number rounded to the nearest thousands. Again, I'm going to look at this number in the hundreds place, and I can see that it is 4 or lower. It is 3, which means that this 0 is going to stay a 0, and 20,320 feet is going to round to 20,000 when I round to the nearest thousands. And finally, Mount Whitney is 14,491 feet. I'm going to look at the number in the hundreds place to help me. It is a 4 or lower, right? Which means that this 4 right here is going to stay a 4, which means that 14,491 would round to 14,000 if I were rounding to the nearest thousands. Okay, so using the rounded rather than the actual heights, we're going to see if we can calculate the number of days it would take someone to climb each mountain at an average speed of 2,000 feet per day. Now, what's interesting about this is that average mountain climbers move at a rate of about 2,000 feet per day as it is. So I want you to think about that, how you might find the number of days for Mount Everest and then write the equation that would be used to show information. So we're going to do this for all 3 of these, and then you're going to have a workbook page to do, okay? So first of all, when we're thinking about the rounded height of Mount Everest, which is 29,000 feet, okay? All right, so we're thinking of the rounded height. Now, if the average person climbs about 2,000 feet per day, think about how many days it would take them to climb Mount Everest. We're going to do the same thing for Mount Denali and the same thing for Mount Whitney. So, if you don't already, go ahead and get yourself a piece of paper, okay? And it could be a page in your student book in the back, or you could simply get a piece of notebook paper, white printer paper, it doesn't really matter. But go ahead and grab yourself a piece of paper, and we're going to solve these problems, okay? So again, we're going to figure out how many days it would take the average person, using the rounded to the thousands, okay, to climb each of these mountains. I'm going to switch my color to blue, and we're going to switch slides here. Okay, so thinking about Mount Everest first. Okay, Mount Everest, rounded to the nearest thousands, is 29,000 feet. All right, so if I wanted to figure out how many days it would take the average person to climb Mount Everest going 2,000 feet per day, I would pretty much want to do 29,000 divided by 2,000. All right, now when I'm looking at the 29,000, well, I know that 2 goes into 28 14 times. So if it goes into 28 14 times, that would mean that it goes into 29 14 and a half times, right? Okay, so if 28,000 divided by 2,000 would be 14, that would mean that 29,000 divided by 2,000 would be 14.5. So it would take the average person about 14 and a half days to climb Mount Everest. All right, I'm going to switch colors here. So moving on to Denali. All right, so for Denali, we have 20,000 feet. All right, so 20,000 divided by 2,000. Ooh, this one's much easier. I know that 2 goes into 20 10 times. Which means that 2 goes into 20, 2,000 goes into 20,000 10 times also. Which would mean that 20,000 divided by 2,000 would be 10 days to climb Denali. About, right? Okay. And then last one, Mount Whitney. So Mount Whitney, rounded to the nearest thousands, is 14,000. So divided by 2,000 feet per day. Now this one's super easy, okay, if I know my facts pretty well. I know that 2 goes into 14 7 times, which means 2,000 goes into 14,000 7 times as well. So it would take the average person about 7 days to climb Mount Whitney. All right, my friends. So I hope that you have done this with me and solved these on your own little piece of paper. You can go ahead and take a picture of it, take a screenshot, whatever you want to do, and post that in Seesaw. And then last but not least, all right, for your homework or independent work, what I'd like you to do is open up your student book to page 147. I want you to complete this page and upload a picture of it in Seesaw, okay? And that is your lesson for today, my friends. Have a